Hello everyone. In this video, let's discuss about recursion. Okay. So when we talk about recursion, we have to remember two things. One is base condition. Another one is recursive condition. One is base condition. Another one is recursive condition. So first we have to know what is meant by recursion. So recursion is nothing but calling a copy of the function itself again and again. So the same function will be called again and again. This is what called as recursion. Okay. So when we write recursion, as I mentioned earlier, we have to keep two things in our mind. One is base condition. What is the purpose of base condition? Base condition helps us to stop the recursion. So we will be keep on calling the recursive call when to stop that recursion. So that will be given in the base condition. So then recursive condition. So calling a copy of function itself again and again. This is called recursive condition. So we have to know these two things. If we know how to write these two things, we can write recursion very easily. Now let's take a sample program called Factorial. Let's write the program of Factorial by using recursion. First, I'll give preprocessor directory hash include stdio.h int main. Fine. I'll get the input value from the user. Scanf %d comma ampersand n. I've got the n value from the user. Now I'll take a variable result. Here I'm going to call a function. So I'm going to give the function name as fact of n. This is called as function call. I'm calling a function. So whatever this function is returning, that value will be stored in the variable called result, and I'm going to print that variable %d comma result. Then I'll give return 0. So here I have called a function called a fact. So let me define that function. Int fact, int n. Fine. Now I'm going to write the function. That is, I'm going to define the function. So here we have to keep two things in mind. What are the two things? Base condition and recursive condition. Base condition. So here, if I want to find factorial of a number, so if I give the n value as 5, I'll be multiplying 5 into 4 into 3 into 2 into 1. I'll multiply all the values, right? So when am I stopping? When I get the value as 1. Okay. So when to stop this recursion, that is given in the base condition. So I'm going to give the condition saying that if n is equal to 1, return 1. So why am I using the keyword called return? Return keyword helps us to come out of the function. So what is base condition I'm giving? I'll start multiplying from 5, then I'll multiply 4, then I'll multiply 3, then I'll multiply 2, then I'll multiply by 1. So when I'm getting the value as 1, I should stop the recursion. Okay. So I'm giving the condition if n is equal to 1, I'll give return 1. What is the value of 0 factorial? 0 factorial value is also 1. So if n value is equal to 1 or n value equal to 0, I have to return it as 1. Fine. If the condition is not true, what happens? I have to go for the recursive call. I'm going to give the recursive condition. I have to go to the recursive call. So when I'm finding factorial, so first I have to take 5. So I'm passing the value as 5. Let's assume I'm passing the value as 5. So if I'm passing the value as 5, first I have to multiply 5. Then this has to be multiplied with remaining values. Now I have to call the recursive call. So recursive call is fact of n minus 1. Why am I giving n minus 1? Because 5 I have got. Now I have to multiply 4. So I have to call a function. So for this I have to write the recursive call as return n into, my n value is 5 into, I have to call recursive call, that is fact of n minus 1. So this we call it as recursive call. Why we are calling this recursive call? Because calling the copy of the function itself again and again. Earlier I'm calling fact of n, I'm calling here. Now inside the function itself I'm calling one more time. So calling a copy of the function itself again and again is called as recursion. So here I have completed the program of recursion. Now let's execute the code and check. Then we'll go see how it works in a step-by-step order. 5 factorial value is 120. Fine. I've got the value as 120. Now we have to know how this recursion works. So let's see this step-by-step execution of the recursion. So let me take this function. Let me write this. So I'll give int fact int n. So here what is the base condition I have given? If n equal to 0 or n equal to 1, I have to return 1. If that is not the case, what I have to do? I have to give return n into fact of n minus 1. So here I have main method. So main method, let me not write everything, just I'll give. So result alone I'll take int result is equal to fact of n. Okay, let me change this color. Okay, so here what is the fact value? Fact value is 5. I mean n value is 5. So I am calling this function. Now n value will be 5 here. Check the condition. N equal to 0? No. N equal to 1? No. So condition is not true. I'll go here. Return n. What is my n value? 5. 5 into, I'm calling a copy of the function itself. So fact of n minus 1. What is my n value? 5. 5 minus 1 is 4. So from here, I am calling a recursive function once again, which means the same function will be called once again here. Int fact int n. So here, what is my n value? In this function, n value is 5. In this function, my n value is 4. Check the condition. If n equal to 0 or n equal to 1, condition is false. So I'll not go inside the if condition. I'll go here, return n into fact of n minus 1. So first what happens? So n value is 4. So 4 into fact of n minus 1. What is my n value? 4. 4 minus 1, 3. Again I have to call a recursion. So same function will be called once again. But this time the value of n will be 3. The value of n will be 3. So I have to check the condition. If n equal to 0 or n equal to 1, condition is false. So what I'll go here? Cut. What I'll do here? Return n into fact of n minus 1. So what is my n value? N value is 3. I'll check the condition. So condition becomes false. I'll go here, return n into, n value is 3 into fact of n minus 1. What is my n value? 3. 3 minus 1 is 2. Fact of 2. I'll call a function with fact of 2. Int fact int n. So in this case the n value is 2. So again I have to check the condition. If n equal to 0 or n equal to 1, condition is not true. I'll go here, return n into fact of n minus 1. Okay. So what is my n value? N value is 2. So check the condition. If n is equal to 1 or n equal to 0, no, I'll go here, n into, what is my n value? 2 into fact of n minus 1. So n minus 1 value is 1. So I'll go for a recursive call. Let me write one more recursive call. So here let me write int fact int n. So n value is 1 here. So first check the if condition. If n equal to 0 or n equal to 1. If the condition is true, I have to return 1. Return n into fact of n minus 1. Okay. So now I'll just change the color so that I can get to it very easily. Okay, I'll take just green. So here check n equal to 0. No, n equal to 1. Yes, condition is true. If the condition is true, what I have to do? Return 1. What is the use of the keyword return? Return keyword helps us to come out of a function. So from this function, I'll come out and this function will return me a value called 1. Where will it return? This function is called by this one. So to this place, it will return me the value called 1. It returns a value called 1. So in this function, I am done with 2 into fact of 1 I have called and it has returned the value as 1. 2 into 1, 2. So return 2. This function got over. 2 into 1, the value is 2. So this function will return me a value called 2 where this function is called by this place. So here it returns 2. Now return n into, so this fact function execution got over. 3 into 2, 6. So this function will return me a value called 6. Where will it return? To this place. Now 4 into 6, 24. So this function will return me a value called 24 to this place. 5 into 24. 5 into 24 is 120. So this function will return me a value called 120. This function is called by this place. So it stores a value called 120 to the variable result. Then it prints the result value as 120. This is how recursion works. So step by step, it calls a function. Now let's discuss about the base condition, the recursive condition. What is the use of base condition? Base condition helps us to stop the recursion. So in this case, when the value of n is equal to 1, I am stopping the recursion. So base condition helps us to stop the recursion. What is the use of recursive condition? It keeps on calling the function. One by one, it's calling us factor of 5, factor of 4, factor of 3, factor of 2, factor of 1. So it calls. Then it returns the value. This is how recursion works. So here we have got the value is 120. Hope we are clear with recursion now. Let's discuss one more example now. Now let's write a program to find the nth Fibonacci number. N Fibonacci number. So with the help of recursion. Okay. So I'll start my program. Hash include stdio.h. The execution of the program always starts from the main function. So I'll get the n value from the user. Int n scan of %d comma ampersand n. Now I'm going to call a recursive function. So I'll give fib of n. So I'm going to find the nth Fibonacci number. So I'm calling a function. This is called as function call. It's called as function call. Whatever the value it is returning, that will be stored in the variable result. I'll print the result value %d comma result. Then I'll give return 0. Fine. I've called a function. Let me define the function here. Int fib int n. Fine. Now let's write the recursion. So when we go for recursion, we have to keep two things in mind. One is the base condition. So base condition is a thing, but I have to stop the recursion. When to stop the recursion? So here, if the value of n is equal to 0 or n is equal to 1, I have to return the n value because Fibonacci series starts with 0 and 1. So 0th term is 0, first term is 1. Then I want to go for second term. If I want to go for the second term, so it should be the sum of previous two values. So this is the logic. Sum of previous two terms. 0 plus 1, 1. Next value. Sum of previous two terms. 1 plus 1, 2. Sum of previous two terms. 1 plus 2, 3. So here I have given n value as 5. Let's assume I am going to give the n value as 5. If I give the n value as 5, the fifth term. So 0th term, first term, second term, third term, fourth term, fifth term. So 2 plus 3, 5. So 5 should be the output value. So if I give n value as 0, the 0th term is 0. If I give me n value as 1, first term is 1. So if the satisfies any one of the case, I have to return my n value. In the previous case I have given 1. But here why am I giving 1? Because of the series. Fine. I have given the base condition. If this is not true, what I have to do? I have to find the sum of previous two terms. So how come I can know sum of previous two terms? So Fibonacci of recursive call, fib of n minus 1 plus fib of n minus 2. Because if I want to know what is my fib of third number, I have to know what is the recursive call of fib of 2 and fib of 1. Then only I can know what is my third term value. Because if I want to know what is my third term, it should be the sum of second term and the first term. So if I want to know fib of 3, fib of 2 plus fib of 1, I'll get my answer. So I'm calling two recursive call. So here what we are doing? Recursive call. So when we have two recursive calls, both the recursive calls will not be called at the same time. First it completes this. Once this recursive call is over, and then only second recursive call will be called. Now I'll trace the code in a step-by-step order, and then I'll explain it so that you can understand it very clearly. So let me run this. If I give me input value as 5, see I've got 5. Right? Let me explain this now. Okay. So here first let me write the recursion. So int fib of int n. So here I have to check the if condition. If n is equal to 0 or n equal to 1, I have to return n. If that is not the case, what I have to do? Return fib of n minus 1 plus fib of n minus 2. Okay, this is the program. N minus 1, n minus 2. Done. Now let's consider the input value n as 5. So let's go for the step-by-step execution. 5 equal to 0 or 5 equal to 1? No, condition is not true. I'll go here, fib of n minus 1. So from here I'm going to call a recursive call. So what I'm going to do? Int fib int n. What is my n value now? 4, because n minus 1 value is 4. So here I'll check the if condition. If condition is not true. If the if condition is not true, I have to give return fib of n minus 1. The second recursion will not be called as of now, because this function execution is not yet over. So when I call a recursive call, so n minus 1. So from here I'm calling the recursive. So from here I'll call. So first recursion I have here in this function, I'm calling this function. So int fib of int n. So in this function the n value is 3. Check the if condition. If condition is false. So what I have to do? Return fib of n minus 1 plus, still will wait here. So from here I am calling the recursive call, because n minus 1, n value is 3, 3 minus 1 is 2. Int fib of int n. So here check if condition. If condition is not true, so I'll give return fib of n minus 1 plus. So n minus 1, what is my n value here? N value is 2. 2 minus 1 is 1. I'm calling a recursive call. So int fib of int n. So here n value is 1. Check the if condition. Yes, if condition is true. If the if condition is true, I have to return n value. What is my n value in this function? The value of n in this function is 1. The value of n in this function is 1. So this returns me a value called 1 to this place. This return me a value called 1 to this place. Now where am I standing? I am standing in this function. In this function, first recursive call got over. Now I have to call the second recursive call, because in the program I have called this recursion. Done. I have got the value of this function. Now I have to go for second recursive call. So plus fib of n minus 2. What is my n value in this function? N value is 2. 2 minus 2, that is 0. So I am going to call one more function called int fib of 0. So check the if condition. If condition is true, n equal to 0 or n equal to 1. See, condition is true. If the condition is true, I have to return the value called 0. So this function will return me a value called 0. Where? To this place. So it returns 0 to this place. Now in this function, first recursion also got over. Second recursive call also got over. So I have to add these two terms. 1 plus 0, the value is 1. The value is 1. So this function will return me a value called 1 to this place. It will return me a value called 1 to this place. Now in this function, first recursive call got over. Now I have to call the second recursive call, that is fib of n minus 2. So I am calling the function called fib of n minus 2. Int fib of, what is my n value? In this function, my n value is 3. 3 minus 2, the value is 1. 3 minus 2, the value is 1. So in this case, my n value is 1 here. Now check the if condition. If condition is true. If the if condition is true, what will it return? It will return me a value called 1. So this function will return me a value called 1, which place? To this place. It will return me a value called 1 to this place. 1 plus 1, the value is 2. 1 plus 1, the value is 2. So this recursion also got over, this also got over. 2 recursive call got over. So this function will return me a value called 2 to this place. Now in this function, first recursive call got over. Now I am going to call the second recursive call. So when we have 2 recursive calls, once the value returned to the first recursive call, then only second recursive call will be executed. Now I'll go for fib of n minus 2. What is my n value? N value is 4. 4 minus 2, the value is 2. So here I am going to call a function, that is int fib of int n. So the n value is 2 here, because 4 minus 2, the value is 2. So here I will be checking the condition. If n equal to 0, n equal to 1, condition false. So I will give return fib of n minus 1. What is my n minus 1? N value is 2. 2 minus 1 is 1. So from here I am calling the recursive call called int fib of 1. Int fib of 1. So check the if condition. If condition is true, n equal to 0, n equal to 1, condition true. If the condition is true, so this will return me a value called 1 to this place. It will return me a value called 1 to this place. Now from here I have to call the second recursive call, because in this function, first recursive call got over, second recursive call fib of n minus 2. What is my n value? 2. 2 minus 2 is 0. So from here I am going to call one more recursive call called int fib of 0. So if condition becomes true, I will return a value called 0 to this place. 1 plus 0, the value is 1. So from here it returns a value called 1 to this place. It returns a value called 1 to this place. 2 plus 1, 3. 3 will be returned to this place. This function will return me a value called 3 to this place. Fine. Now in this function, 3 has been returned to first recursive call. Now I have to call the second recursive call, that fib of n minus 2. N value is 5. 5 minus 2 is 3. From here I am going to call one more recursive call. From here I am going to call one more recursive call with int fib of int n. So here the n value is 3. So when I see here, listen. Okay. Here remember one thing. Already int fib of 3. So these many recursive call, whatever I have called here, the same recursive call will be called once again. These many recursions will be called once again in this place, because I have called the function called int fib of int n, right? So these many recursion will be called once again to this place, and in this function here it will call, and this function returns me a value called 2. It returns, because int fib of 3, here it returns a value called 2. So once again the execution will be done here, and it will return the value called 2 here. Okay. Now this function also got over. 3 plus 2, 5. So this function will return me a value called 5 to the main function. That is why I have got the output value as 5. This is how recursion works. Fine. So I have got the output value as 5. So I hope you are clear with the recursion. Okay. So when we go for recursion, just we have to keep two things in mind: base condition, recursive condition. So base condition helps us to stop the recursion. Recursive call just to call the other function. So you can have n numbers of recursive call. You can have 1, 2, 3. You can have these many recursion, but you have to keep one thing in mind. Once this recursion has been called, until it returns the value to this place, then only the second recursion will be called. So it doesn't mean the two recursion will be called parallelly. No, it's not like that. First I'll call this recursion, value will be returned to this function, then only I'll call the second recursive call. Right? That's all.